Hey, Psych230 students, welcome to week 6. So this is our check-in video for this week. So this is the second week of this section. So that means that at the end of this week, due next Sunday, will be exam number 3. So just kind of heads up in terms of where we're heading going into this week. So you've learned 2 T statistics so far. So you've learned the single sample T and the independent T. Those are chapters 9 and 10. You're only going to learn one more chapter this week. That is chapter 11, which is technically called the dependent T statistic. So what you saw in the single sample T, you had one group measured once. And we're just looking for, are they noticeably different from some population mean that we can infer or might already know. Then in chapter 10, in the independent T, we shifted and we started talking about comparing 2 different groups of people. So now we have 2 sets of scores. So what you saw was double the number of calculations. You also see that we start using a subscript in some of the symbols, which makes the formulas look worse, even though they aren't that hard. Because we have to calculate a mean for both groups, a variance for both groups, a standard deviation for both groups, and then this thing called estimated standard error and all this stuff. So it looks complicated. It is one of the longer statistics that we do, is the independent T. But again, just sort of thinking about the setup, it's got 2 sets of scores coming from 2 different groups of people. And that's why it's called the independent T, is because the 2 groups are independent of each other, meaning that they are different people. What you're going to see in chapter 11, what we call the dependent T statistic, as you might guess, we're going to still have 2 sets of scores. However, those sets of scores are going to be dependent on each other. Now, what you'll learn in the chapter 10 lecture videos is there's 2 ways basically we can get 2 sets of scores that are related or dependent on each other. One is to do what's called a within subjects or repeated measures design. And that's simply where you take one group, you measure them, and then you do something, and then you measure them again. Okay, so it's a typical what we call pre-post kind of research setup. So you get a pre-test score, and then maybe we give them an intervention, and then you get a post-test score. So like in psychology, that would be like, all right, in the psychotherapy and does it work with depression, we would measure people's depression. So we find a bunch of people who are currently depressed, measure the depression level, then give them, so that's one set of scores, and then give them 10 weeks of psychotherapy, and then measure them again at the end of the therapy. And what we would hope to see is that the depression scores have gone down. Now, that second time we measure them, those scores are actually dependent on the first scores because essentially it's the same people in each group. So what we end up actually doing is looking at a person's 2 scores. So if I was in the study, we would look at my pre-test depression score and my post-test depression score and see if it changed. Did it go down? We would do the same for you if you were a participant. We'd take your pre-test score and your post-test score and look for a difference. And difference in math is subtraction. So that's going to be the way we're going to be doing the examples of the dependent T, is where it's one group measured twice, before and after some kind of treatment. There is another way you can get dependent scores, and that's where you might have 2 different groups, but they are matched. It's what we call a matched design or matched subjects design. And essentially what you do is you would measure people ahead of time on some variable and match them. And so in our psychotherapy and depression study, we might take, because what we might expect is people who are more depressed have farther to come down. So they might get less depressed over time because they're just so extreme when they start. So what we do is measure everybody's depression level ahead of time. And then we'll match people. We'll take the 2 highest depression scores. Those people are essentially matched because they have high levels of depression. They're similar. One will, so then we'll essentially give one the 10 weeks of psychotherapy. The other would get no psychotherapy. And then at the end of that 10 weeks, we measure both of them. Now again, they were both the same level of depression at the start 10 weeks ago. Now at the end, after one got therapy and one didn't, are they now different? And so we do that. We just take the next 2 highest scores, match them, and so on. And so this is what we call a matched subjects design. We're not going to use that in our examples, just so that it's a little bit easier for you to always identify what statistic to use. But again, technically the idea is that we're going to pair up scores because they're dependent on each other. They, in this case, were matched based on some pre-existing characteristic, this level of depression. So that's the main chapter that you're going to learn this week. The reason why it's only one chapter this week is partly because we have the exam, but then there's also 2 deep dive assignments, one for the independent t statistic and one for the dependent t statistic. So you're going to be learning how to run an independent t and a dependent t on Jamovi. These are going to be important partly because most of you, in particular, the independent t is going to be important because most of you are going to need to use the independent t for your research project. Most people have 2 different groups of scores coming from independent groups of people. And so when it comes to running the statistics for your project, you're going to calculate by hand an independent t, and you're going to also run it through Jamovi as an independent t. Some of you, I can't remember, but some of you might have a dependent t setup where you're going to do a pre-test and post-test for your research project. So then that deep dive assignment will be particularly helpful for you. But both of them will be helpful because they'll help you, again, start to understand how to interpret those t statistics and then also how to write them up. Be ready for that. So there's a couple extra assignments this week that are the deep dives, and so that's why I wanted to only just have the one chapter. The other thing that I think is really important to note is that for exam 3, there is a new question. It's what I refer to as a 20-point question because it's obviously worth 20 points. And it is a question where it is a computational question, but what it's going to be is a hypothesis test from start to finish without me giving you all the prompts of all the steps. So in other words, what it'll be is a paragraph describing a research study. So it'll tell you what you need to know and also give you an alpha level and how many tails you're supposed to do and all that. But then it will just give you a table of data. And your task will be to figure out which of the 3 t statistics to apply. So you might determine that it's a dependent t statistic, so then you'll apply that one. And once you've decided that, you then do all of the calculations. You run the hypothesis test start to finish, and then the answer on WebAssign will be the write-up that we write for the literature. And now you're seeing that I'm emphasizing how we write things in the literature more and more now, because that is one of the most important outcomes of this class, is that you all can read the research literature and understand what's happening in the results section. Best way to do that is have to write parts of those results sections. So that is worth 20 points. And the real important part is there is partial credit. So let's say you write your 2 sentences and some of your numbers are way off, but the sentences and all that make, it's sort of written in the right template, and just a couple of the numbers are off. Then I'm going to go look at your work, look at your hand calculations to see where things went wrong. Because at this point, your answer's wrong. But let's say you just made one little math mistake early on, which is often what happens. People make a mistake in squaring their scores or adding up those squared scores or calculating sum of squares. That's usually the most common area. So you made a mistake there. Well, then it throws off everything after it. As far as I'm concerned, that was only one mistake. And so you would get 19 out of 20 points. But if you made a couple different errors in different places, or you didn't write the results in exactly the right way, or you chose the wrong statistic, then I'm taking more points off. So there's lots of partial credit for that 20-point question. So it's really, really important that you upload your work. Now, again, best way to upload work is to scan your work. So do by hand your calculations, then scan that. Now, if you don't have a scanner, my suggestion is that you use your phone as a scanner. Rather than, you can take a picture, but it works better as a scanner. It's a smaller file. It's easier to put all of the work in one document rather than having a number of different pictures. Apple phone or iPhones do it just automatically in the Notes app. If you open up the Notes app, create a new note, and then in the bottom there's a little camera icon. If you click on that, it essentially will take a picture, and you can just keep taking pictures, and it will essentially do it as a scan and put it into this document. And then you just upload that document to WebAssign, or if you have any problems with that, just email it to me. If you have an Android or I don't know what the Chrome or Google phones are called, then you'll want to look for some apps. There are apps that are just for free that will convert pictures into PDF. So again, you can use your phone camera and that will then allow you to convert it to a PDF, and it's much nicer. So if you can do that, that works. If you can't figure any of that out, just do pictures and it's fine, or screenshots, whatever you need to. But be ready for that 20-point question. So let me just tell you quickly about the test. The test only covers chapters 9, 10, and 11. So exam 3 is only focused on the T statistic. And so there is the 20-point question in the computational section, but I am also going to test you on all 3 statistics. So the 20-point question is only going to be focused on one of the T statistics, but there will be a bunch of 3-point questions for each of the 3 T statistics. So I need to know you can do all 3. So there will be some questions, computational questions that are about the single sample T. There will be some 4 or 5 that are about the independent T, and there'll be 4 or 5 that are about the dependent T. But those will be asking you to calculate certain parts, in a certain order, and so on. So it's more like your problem sets. Also, I just want to remind you that there are the calculation videos. So when you're getting to that point of having to do a whole hypothesis test start to finish, those are really useful. Also, I would really highly suggest just writing one out so that you have how to do it start to finish. So when you get to the test, you'll just say, oh, I've figured out which T statistic it is. Where's my example of that? Pull it out, boom, and then you just follow along. So that's just the computational side. And then there's still some multiple choice, but again, only focused on chapters 9, 10, and 11. So I think on this test, I would say there's like 18 multiple choice questions, each worth 2 points, and then the rest are computational. And a big chunk of that computational is that 20-point question. So just be ready for that. Otherwise, I think we're, it's kind of same as usual. We'll be going through, just have a few more deep dives this week, but definitely be ready for exam 3. And if you have, again, any questions, again, reach out. I'll be sending some Muddy Point review for both chapter 9 and 10 here in the next few days. All right, thanks.